Okay, in this video we're going to be talking about continuity or discontinuities. The, the the intuitive idea of continuity is that a function is continuous if there's no breaks in the graph. Or another way to think of it, you may have heard this before, is if you can draw the graph without ever picking up your pencil. So that's just the intuitive kind of understanding of what continuity is. But for calculus, we're going to learn the actual definition of continuity. So how do you define whether there's a discontinuity at a point or not? And that's the topic of this video. Now let's just run through the intuitively first, though. So I have an example of four different functions here. So this first one, notice that there's clearly a break in the graph. Let me grab a highlighter here. Okay, you can see that the graph kind of falls apart right there, right? Likewise, on the second one, there is a break right here that you would have to pick up your pencil when you're drawing from the right side. You have to pick it up and put it back down to draw on the, when you're drawing the left side, you have to pick it up and put it back down to draw on the right side. And down here, there's several discontinuities. You got one right about here, and then there's another little hole right there, right? Those are all breaks in the graph. And then finally, this last one is an example of a continuous function. There are no breaks, even though it does stop somewhere, but there's no breaks in the graph. It doesn't stop, but it doesn't go below the x-axis, but there are no breaks. You could draw this entire graph without ever picking up your pencil. So that's the idea of continuity. We have three functions that are not continuous across their entire domain. Now notice this function, the first function, is continuous everywhere except for at x equals 1. It has one spot of discontinuity. Same way with the second one, only has one spot of discontinuity. This third one has three different points of discontinuity, and then the last one, of course, has none. So, but now let's talk about it in a more formal definition. So what does it mean for there to be a discontinuity? So I would say in this case, there is a discontinuity at x equals 1. And we always describe where something occurs with an x coordinate, right? So we know there's a discontinuity at x equals 1. How do we know there's a discontinuity? Well, if you look at the picture, you can just tell that there's a break in the graph. But formally, and by definition, how do we know there's a break in the graph? So there's a three-part test to the definition of continuity. First test, in order for it to be continuous, there has to be you have to be able to find a functional value at the point. So in other words, f of, in this case, 1 exists, because we're checking at x equals 1. So does f of 1 exist? Yes, it does. So you can see a dot right here. So when you plug in 1 into this function, you get out 1, right? So that checks the first part of the definition. The second part of the definition is the limit of f of x as x approaches 1 also has to exist. And that's where this one falls apart. So notice that in this case, if we talk about right and left-hand limits, so as x approaches 1 from the left side, I'm approaching 3. As I approach x from the right side, the limit is approaching -1. So since the left hand and right hand don't agree, that means that this limit does not exist. And that is the reason why there's a discontinuity there, because the limit does not exist at that point. Okay, so let me jump down here real quick and then we'll come back and look at these definitions. So the formal definition of, f of x is continuous. At x equals a if f of a exists means that you can plug in a and get out an answer. The limit as x approaches a, limit of x as x approaches a, also exists. And then finally, last but not least, they have to be equal to each other. So the limit of f of x as x approaches a must be equal to f of a. So three-part definition. It has to meet all three criteria in order to be continuous at that point. So generally when we're asking the question, is this function continuous? We say, well, I think it's continuous ever except at x equals 0. Because clearly there's a nice smooth line there, smooth line there. So I'm going to check at x equals 0. So the first thing I have to do is I say, does f of 0 exist? In this case, the answer is no. Does not exist. So I stop, move on. There's no reason to keep going because I've failed the first criteria. Go down to this one. I notice there's 3 troubled areas. So I'm going to check at x equals -2, x equals +2, and 3, 4, 5, x equals 5. So when I go to check, does f of -2 exist? And the answer is no. Does not exist. That's why there's discontinuity there. How about right here? Does f of 2 exist? No, does not exist. That's why there's discontinuity there. What about at 5? Does f of 5 exist? No, does not exist. There's nothing there. Okay? So these all have all these are discontinuities because they don't pass the first part of the definition. So let's back up a second and say, let's say there actually was a point right, I don't know why I said 5, 1, 2, 3, 4, it should have been 4.5. Sorry about that, folks. 4.5. 4.5 is what I meant to say, okay? Let's say that there actually was a point right there. And let's redo 4.5. So we'd ask the question, does f of 4.5 exist? And the answer is, sorry, my son just came in and had a question. So let's see, where are we? So does f of 4.5 exist? And the answer is yes. It looks like it's equal to 1. Yeah? So then we take the limit of f of x as x approaches 4.5. And as we come from the left, it seems to be approaching about 1.5. And it comes from the right, it seems to be approaching the same thing. So we say about 1.5. So that also exists. So that passed the first criteria, passed the second criteria. And remember, the third criteria is those two have to be equal to each other, and they do not. 1 is not equal to 1.5, and so therefore it fails. So it is still a discontinuity, but for a different reason than before. Okay? So that's the three-part, that's the definition of continuity, which is, you can think of it as three-part definition, or you can think of it as a definition with 3 criteria. So in order to be continuous at a point at x equals some number, then the function has to exist at that value. The limit has to exist as x approaches that value, and the limit and the function limit value and the functional value have to be equal to each other. So that's definition of continuity.